Hello everyone, welcome to easyedu, and today we are going to discuss about velocity time graph. Here is a velocity time graph where the x-axis represents the time and the y-axis represents velocity. Now in this chart, the region from O to A indicates that there is an increase in the velocity, and the increase in the velocity means there is acceleration. But this line is a straight line which indicates the acceleration is constant. So we have a constant acceleration in this region where the speed increased from O to A. Now from A to B, we see there is no increase in the velocity, and when there is no increase in the velocity, the acceleration is zero. When the acceleration is zero, we can say the velocity in this region is constant. Now from B to C, the speed reduces back with a constant deceleration because this is a straight line, so the deceleration is constant. Now there are two things we can calculate from a velocity time graph. From velocity time graph we can calculate acceleration, and acceleration is equal to gradient of the graph, or we can say slope of the graph. So if we take the slope of this chart, the slope of a velocity time chart, we will get acceleration. And the second thing that we can calculate from the velocity time graph is distance or displacement travel, and this is equal to area under the curve or area under the graph. Now let's discuss it in more detail here. Now here in this chart, the y-axis represents velocity and the x-axis represent time. Now the region from O to A, we see increase in the speed or velocity, which means there is acceleration, and this acceleration is constant. So the slope of the velocity time graph is equal to acceleration. Now let's calculate the slope of this O to A region. The slope we know is equal to y2 minus y1. The y2 is this position, which is equal to 3 here, while the y1 is the initial position of the y-axis, which is equal to 0, and divided by x2 minus x1. X2 is the final position on the x-axis, which is 2 here, and the initial position is 0. So the slope of this chart, m, will be equal to y2 minus y1 x2 minus x1 divided by x2 minus x1. Now this side, the rise in the graph indicates the y-axis, and this represents the x-axis, the change in the x-axis. The change in the y-axis we know here is velocity. So there is change in the velocity, which is vf minus vi divided by t2 minus t1. Acceleration is equal to v2 minus v1 divided by t2 minus t1. The slope of a velocity time graph is acceleration. Now substituting the values here for this region, we will get 3 minus 0. 3 is the final position, the final velocity, and 0 is the initial velocity. So 3 minus 0, and here we will get on the x-axis 2 minus 0, which is equal to 3 divided by 2, and we will get 1.5 meter per second square, the value of acceleration. Now in this region from A to B, there is no change in the acceleration. Now in this region from A to B, there is no change in the velocity, and when there is no change in the velocity, we can say the velocity is constant and the acceleration is equal to 0. Now from B to C, there is a constant deceleration, and the velocity starts decreasing here, while reaching the C point here, the velocity reaches to 0. And this region from C to D indicates that the object is at rest. There is no change in the velocity here is equal to 0. The final velocity and the initial velocity both are equal to 0. So 0 minus 0 is equal to 0, and dividing by change in the time, 6 minus 5 equal to 1. So 0 by 1 is equal to 0. Now from the position D to E, there is a constant deceleration, and this acceleration is in the opposite direction. So the value of the acceleration here, or the acceleration, is in the negative direction. Let's calculate the acceleration in this region. The y-axis here is the final position on the y-axis is minus 2, and the initial position is 0. So we will have minus 2 minus 0, while the time is from 8 to minus 6. So 8 minus 6 is equal to 2. we will have minus 2 divided by 2, which is equal to 1. And the slope of this DE region is minus 1 meter per second square. While from E to F, we see there is no change in the velocity, and which indicate a constant velocity with zero acceleration. So the slope of a velocity time graph is acceleration, which is equal to v2 minus v1 divided by t2 minus t1, or the y-axis divided by the x-axis. Now let's calculate distance traveled. The distance traveled can be calculated from the velocity time graph, and the distance traveled is equal to area under the curve. Let's consider we have 0a and then c. So area under this line in this region will give us the displacement it has traveled during these 2 seconds of time. Now for calculating displacement, we will need to find the displacement of this whole region. To make it more simplified, we divide this region into two regions. One is this triangle and the second one is this rectangle. So area in the triangle region is equal to 1 over 2. We know area per triangle is equal to 1 over 2 length multiplied by height. So here the length is 2 meter while the height is 3 meter. The y-axis, which indicate velocity, is 3 meter. So we will have 1 over 2 multiplied by 2 multiplied by 3. This 2 will cancel with this 2. The distance traveled during these 2 seconds is equal to 3 meter. Now for the remaining 2 seconds of time, we will have displacement d is equal to length multiplied by width. Now here in this case, it is a rectangle, and the rectangle, this is the width, the length, and this is the width. So length multiplied by width, we will get 3 multiplied by 2. 3 is the vertical length. We consider its length or height, and this is the width. The width is considered as 2 meters. So 3 multiplied by 2 is equal to 6 meter. So the displacement it has traveled in these 2 seconds is equal to 6 meter, which is more than the initial because here the velocity is high. While in the first 2 seconds, the velocity increased from 0 to 3 meter per second, while here the velocity was continued as 3 meter per second. So the total journey it has traveled in these 4 seconds is 6 plus 3, which is equal to 9 meter. So it traveled 9 meter during these 4 seconds of time, and the area under the curve of velocity time graph is displacement. That's it. Thank you for watching, and do not forget to subscribe easyedu for more videos.